So we're going to have a look at graphs that come in the form of y equals kx to the power of n. And what we're going to do is first of all have a look at what this n here does. So let's not worry about k for the time being. It's n that's the important thing. And the n always determines the shape. So don't worry about how it does that. What we need to know is that whatever the n is will make the graph a certain shape. So when n equals 1, which is the case that we're most familiar with now, then we have a straight line. And that would be something like an equation of y equals 3x. Okay, when n equals 1, then that would make this y equals x to the power of 1. Let's forget about k, remember. And anything to the power of 1 is itself, which means it would be y equals x. Now, y equals x, that, if we consider that in the form of y equals mx plus c, then m would equal 1, because 1 times x is x, and c would equal 0. And because we can make it fit this format of y equals mx plus c, then the line y equals x, that would be a straight line. So therefore, when n equals 1, we have a straight line. So now let's have a look at some other values of n. And we're going to go into the positive values. Now, when n equals 2, that means that our function will look something like y equals x squared. Remember, right now we're ignoring k. So y equals x squared. And y equals x squared is always what's called a parabola. And parabolas always look like smiley faces or sad faces. So if I were to sketch a parabola, it'd look something like this. So we have our axes here, and really we should make sure we label the axes. So that would be y, and that's x, and we should always do that. So that was quite remiss of me. So there we go. And the parabola, the smiley face, always goes through the origin, and it goes up like that. So my parabola, it's meant to be the same on both sides, so let's try and make that a little bit better. So it looks like a smiley face. It always goes through the origin. And a parabola that has the equation y equals x squared always goes through the point 1 and 1. And this is going to become important later. It's probably not that important right now, but keep that in mind. A parabola that has the equation y equals x squared always goes through 1, 1. So that's the second thing. When n equals 1, we have a straight line. When n equals 2, we have something about x squared, and that always looks like a parabola. Now, let's have a look when n equals 3. So now, when n equals 3, then we have something that takes the form of y equals x cubed. And this is, believe it or not, called a cubic, because y equals x cubed. Now, cubics look like this. They look a little bit like sort of parabolas for the second half, a little bit. They're not exactly the same, and that shouldn't go out at the top. So let's draw that again properly. They look like that, but the other side, they come down. And so they look exactly the same if you rotate this around. So a cubic looks something like that, and this would be y equals x cubed. And cubics also pass through the origin, always, or cubics in this form always do, and y equals x cubed also passes through 1, 1. So it's worth keeping that in mind as well, because they have a few things in common. So now let's have a look at what happens when n is a negative number. Now when n's a negative number, we have this thing going on. So let's say n, let's try again, shall we? Let's say n equals negative 1. This is called a hyperbola. And what happens is because we have an equation that'll be something like y equals x to the negative 1, that's also exactly the same as y equals 1 over x. And we know when we have a fraction, if the denominator equals 0, then we don't have a possible number. Anything over 0, that's when everything goes horribly wrong. So that means when my x value is 0, which is here, my hyperbola, my 1 over 0, doesn't exist. My hyperbola function actually looks like this. So as it approaches really, really close to 0, then my numbers get really big, but it never actually gets there. The same thing happens with this x-axis. As my numbers, as that goes along further and further and further, it gets closer and closer to the x-axis, but never actually gets there. In the negative numbers, it looks like this. It's the same sort of thing. It gets closer and closer, but never gets there to these axes. Now that's called an asymptote, and I'll write that down. So when something does that, the x-axis or the y-axis is the asymptote. And that means that the line gets closer and closer and closer to the line, to the axis, but it never actually touches it. Not even if you go way, 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 way to massive numbers. And the other thing to keep in mind when we're dealing with a hyperbola, it doesn't pass through 0, 0, but my asymptotes cross at 0, 0. But again, if it's y equals 1 over x, then it will pass through the point 1, 1. So that's the graph of y equals 1 over x, or when x equals negative 1. So now let's have a look at what happens when n equals negative 2. And when n equals negative 2, we have a shape that's a little bit similar to the hyperbola, and it's called a truncus. Now, remember, when n equals negative 1, then the power of negative 1 means it's 1 over x. When n equals negative 2, then we get 1 over x squared. So this is what it looks like. My negative means that the x is down the bottom side and the 2 is the power. So we need to understand when n equals negative 2, we're looking at some sort of truncus which has the equation y equals 1 over x squared, or something like that. Remembering again, we're not looking at the value of k. And a truncus looks quite similar to a hyperbola, except both bits of it go above the axis. So that's not a very good one, so let me try and draw a better one. They're meant to be symmetrical, it's meant to look the same. A truncus, would you believe, also would go through 1, 1 if it has the equation y equals 1 on x squared. And it's called a truncus because it looks a little bit like a tree trunk. So that's what my truncus would look like. Remembering as well that a truncus has the same sort of asymptote behavior here and here and here that my hyperbola has, which means as the line gets closer and closer and closer to the y-axis, it will never ever get there. Just like here, this line will get closer to the x, but it will never ever get there. So truncus and hyperbolas have things in common, and the parabolas and the cubics have things in common as well. So now we know what the value of n does as far as the shape of our graph. So now let's have a look at what k does. Now k is what's called a dilation. So I'm going to write here dilation. And what k does is it will stretch the graph this way. So therefore, if I had something like, let's have a look at the parabola for example, and we'll see what happens when we get a k value or different k values and what they do. So let's imagine we start off with a parabola like this, and here we've got y equals x squared, which is the same as y equals 1x squared. So therefore k equals 1. Now, if we increase the value of k, remember, k stretches it this way. So if we increase the value of k and make k2, what happens is all of these points get stretched up away from the x-axis. And we'll have a parabola that looks something like this. So that would be when k equals 2. So therefore, y equals 2x squared would look something like this. And my point back here, remember how we had the point that was at 1, 1 on my original parabola? That's now going to be stretched upwards, so my y value is stretched, and we'd have the point 1 and 2 on our new one. Imagine, on the other hand, we had a k value of 1/2. What's that going to do is it's going to do the opposite of stretching, and you'd end up with a parabola that looks something like this. And my point here, that was where the 1, 1 was, that's going to be at 1 and 1/2. So this would be y equals 0.5x squared. So k stretches up and down. You'll notice the points at the origin, every single one of these graphs still passes through 0, 0. So all of them do that, but the points away from this horizontal line all get stretched. And the same thing happens with cubics, hyperbolas, and truncus. So when we have a k number, what it does is it stretches in the vertical direction away from the x-axis. If you found this video helpful, please like the video, or even better, subscribe to my channel. Thanks.